Alright, so this is problem 83. So this one says that there is a frictionless horizontal ice rink. So it's frictionless horizontal. There's a skater. So a dude that's like doo 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 doo. And he's skating on the ice with his little ice skates because he's really cool. And that's a really cool picture. That's anyway. So he's moving at a speed of 3.0 meters per second. And then he hits a patch of sketchy ice. And that reduces her speed. This is a female skater. So we'll give her a dress, I guess. Because sexism and gender stereotypes. Anyway, so she hits a patch of rough ice, and we're going to give that a distance of x, because we'll come back to that later. And it reduces her speed down to, I'm going to do like a dotted arrow, because this is the after speed, to 1.65 meters per second. And that's due to a friction force that is 25% of her weight. So 25% of m. And this is important because this comes back to it. So then it asks us to use the work energy theorem to find the length of this rough patch. So that's the x that we talked about earlier. So with this, it's pretty straightforward. You're going to have the momentum or the energy from the kinetic speed, and that's going to be equal to, so this is like the before, then she hits the rough spot, and then you're going to have the friction plus her remaining speed, which we know is that. So you have the initial and final speed, so that's k naught and k, and that is equal to 1/2 times the mass times velocity squared, and we're going to put initial there, and that is equal to 1/2 times her mass times her velocity squared. That's the final velocity, so that's that one there. And then in addition to that, you're going to have the friction, which is mu of k, since she's moving, so it's kinetic friction, times the normal force, so Fn, times the distance traveled. So for this, it's pretty easy, some of the things you can do, because this guy here breaks out to be mass times gravity. And then once you have a mass in all three of these, you can go ahead and divide those out. And then you just kind of like move everything over to the one side. One thing I did is I multiplied everything by 2 to get rid of those 2 1/2s and just added in a 2 over here. Just makes it a little simpler on the calculator. So then you have v naught minus v squared over mu g equals x. Once you do that all, so let me just rewrite what we've done already before I jump too far ahead. So this is what we get once we multiply everything by 2 and divide by m. So then you can get v naught minus v, so both of those are squared, all of that over 2 mu kg, and that's going to equal x, or your distance, or the size of that rough patch of ice. So we were given some of these already, so we can go ahead and write those out. So v naught, her initial speed is 3.0 meters per second. Her final speed is 1.65 meters per second. And then we know that this, the friction is equal to a fourth, or 25% of her weight. So it's going to take the weight, which is the normal force, and bring it down to a fourth of that. So this mu is going to equal 0.25. Which is pretty reasonable, actually. And then gravity equals 9.81 meters per second squared. And at that point, I think you have everything you need to solve that. And so if you just go ahead and plug that in, you can just put that straight into the calculator, and then you come out with 1.2798 something, so it rounds to 1.3 meters long. Boom.